Hi, welcome to this quick how to help video on regular polygons and finding missing angles. It might not be that quick, because what I plan to do once I've shown you how this works is to do a second one here. Regular polygons and the questions that you can get can look so different each time that I thought it might be helpful for you to be able to see a couple of examples. So let's get straight into this. The word regular is going to be used and is absolutely key, because without that knowledge and what it triggers, you won't be able to get started, because as you can see, they don't give you a starting angle. It's your job to find it. So when you read that word regular, you really want it to trigger a formula triangle where 360 is in the top, you've got your exterior and your sides at the bottom. They're talking about two regular pentagons. Pentagons have 5 sides. So I have the information I need to use this triangle, dividing 360 by 5, which is giving me 72 degrees. And that 72 degrees is, of course, the exterior angle. So what is an exterior angle? It's the angle on the outside of the polygon. But if you take a little look, if I draw that in, which might be what you think is an exterior, you can see that that doesn't look like 72 degrees. Even though the diagram's not drawn accurately, you get a feel for that not being the right thing to do. An exterior angle lies on the line, so that if you stretch the side out, it will lie on that extended line. So that is my 72 degrees, which is on a straight line with the interior angle, which will be, of course, 108 degrees. And that's because of my straight line rule. So once I found the exterior and I've marked that onto my diagram, I can easily get into the diagram with the interior being 108. My knowledge of regular, my understanding that that means all the angles are equal, it means that all these angles are going to be the same. And because this is an identical pentagon, so will these. So I've just found a huge number of angles. So I know that this and this is 108. Now that is really close to the A and the B, so that's going to be helpful, definitely. I can see that this is going to be angles around a point. So I know that that property is going to be coming into play, but I'm not going to be able to find A unless I've got B, or B unless I've got A. So there is more to this problem. Because our pentagons are regular and they're identical pentagons, it means that this side here and this side here, even though they're not on the same pentagon, will be equal. So if I mark that on, you can now see that I have got an isosceles triangle. So that's being buried within the diagram. And this happens all the time with regular polygons. You need the triangle to get you started, to get you that first angle. And then there's going to be all sorts of additional things that you would be using along the way. We've already used the straight line. I'm now going to use isosceles triangles. These two angles here are going to be equal. And I know they sit on a straight line with these angles that are on the inside of my pentagon. So my missing angle here is 72 and 72. So I can now find my angle A, no problem. Angles in a triangle add up to 180. Take away the two 72s that I've got, and I can see that my angle A is 36 degrees. Now that I know A is 36 degrees, I've got everything I need to help me find B. B, using angles around a point, is going to give me 360. Take away the 108 and the other 108 and the 36, and I'm left with the missing angle, which is 108 degrees. So no matter how complicated the diagram looks, your first step is to get that triangle triggered. That needs to be trained into your brain so that you can get your starting angle. And the other thing that I would really point out is just look how much I am marking the diagram. every new piece of information goes onto the diagram where I can see it and my brain can process it. I'm not doing it away from the diagram. So that would be a really important top tip. Okay, if you wanted to stay with me and have a look at this one here, you're very welcome. Otherwise, that is pretty much it for information on how to do missing angles in regular polygons. Now, if you're sticking with me and you want to give this a go first, hit pause and then press play when you're ready. Okay, so we're looking at a regular octagon. So 360 divided by 8 is going to give me my 45. And I'm just going to mark that on so that I can then mark on the interior being 135. So I now know that every single one of these interiors is 135. Now, the way that I move around the diagram may be different to the way you move around the diagram. This is one of the things with angles. There's loads of different ways and approaches that you can take. My eyes are homing in on this line here. It's actually splitting my octagon in half. So if I'm splitting the octagon in half, then my interior angle of 135 will be split in half. And that will give me my result for A. So A is 67.5 degrees. Now I'm going to start concentrating on the B. I can see that B is kind of wrapped inside this triangle here. And this triangle is an isosceles triangle because this edge and this edge come from the octagon, and the octagon is regular, meaning all the sides are equal. So those equal sides now have created an isosceles triangle for me. I know that this angle here is 135. Let's get that in, because it's the interior angle of the octagon. And all I now need to do is use my knowledge of triangles. 180, take off the 135 will give me 45. And that 45 degrees needs to be shared out between these two. So I divide by 2 and my final answer is 22.5 degrees. So B is equal to 22.5 degrees. Okay, I hope you found this quick how-to a useful one, and hopefully I'll be able to help you in the future. Thank you for watching this Target Maths video.